Take a look at the last page here, Coordinate Geometry Midterm Review. For all these problems, I'm going to do the even problems without using a formula, and the odd problems with using a formula. Here we go. Find the distance between each pair of points, put your answer in simplest radical form. Number 12 I will do without using a formula. So for distance on a coordinate grid, I always just make myself a right triangle here. And count the length of the sides and use Pythagorean theorem. So 1, 2, 3, 4. 1, 2, 3. Alright, and Pythagorean theorem says that a squared plus b squared equals c squared, where c is the longest side. So 4 squared plus 3 squared equals, let's call this x. X squared. 4 squared is 16, 3 squared is 9. Going down the x squared, add them together, you get 25 equals x squared. And the square root of both sides. The square root of 25 is 5. So this length is 5, or the distance is 5. This one, number 13, I will use the distance formula. Now it's a little big and clunky, but if you care to remember it, here it is. y2 minus y1 squared plus x2 minus x1 squared, all under the big square root. So we need to get some coordinates out off of here. So this coordinate is, let's see, negative 3 comma, 5, and 1 comma 1. Again, there's a lot of work here. I'd really recommend doing it this way that I did number 12, but just in case you like this, let's keep going. y2 is going, let's call this point 1 and point 2. y2 is 1 minus y1, which is 5 squared, plus x2, which is 1, minus x1, which is negative 3, so minus negative 3 is plus 3 squared, big square root. 1 minus 5 is negative 4 squared, plus 1 plus 3 is 4 squared, big square root. Negative 4 squared is 16. Remember, when we square a negative, it becomes a positive. Plus 4 squared is 16. 16 plus 16 is 32. And we shouldn't stop here, remember, because we need to simplify our square roots. Simplest radical form. So, let's see, what can I pull out of that 32? Well, I know that 32 is 16 times 2, and 16 is a perfect square. So, 16, 2. The square root of 16 is 4. And 4 radical 2 is my answer. For 14, I will do without using any sort of formula. I also look at the change in y, the change in x, and use Pythagorean theorem. So how far is it from, let's see, from 5 to negative 1? Well, from negative 5 to negative 1, let's see, I'm increasing by 4. From negative 8 to 4, I'm increasing a whole bunch. Negative 8 to 0 is 8, another 4 is 12. Alright, so that means that I can use Pythagorean theorem here, a squared plus b squared equals c squared, and I know that my change in y is usually my a, so 4 squared. My change in x is usually my b, 12 squared equals that distance squared. 4 squared is 16, 12 squared is 144. 144 plus 16, let's see, 16, 150, 160 equals c squared. Take square root of both sides, and what perfect square is in 160? Well, 16 goes into 160, so I can break this down into, let's use some space up here, break that down into square root of 16 and square root of 10. The square root of 16 is 4, and the square root of 10 I cannot do anything else with, so 4 radical 10, again, simplest radical form. For 15, I will use the formula. Again, y2 minus y1 squared plus x2 minus x1 squared. So let's label my points, x1, y1, x2, y2. So y2 minus y1, so minus negative 1 is plus 1 squared, plus, let's see, x2, 7, minus x1, 5 squared. 8 plus 1 is 9. 7 minus 5 is 2. 9 squared is 81. 2 squared is 4. Don't forget my big square root. 81 plus 4 is 85. And then we have to ask us if there are any perfect squares that go into 85. Because we need simplest radical form. Let me take out my calculator over here. So 85, what are my perfect squares? Does 4 go into 85? No. Does 9 go into 85? No. Does 16 go into 85? No. Does 25 go into 85? No. Does, what else? 36? No. I don't think there are any perfect squares that go into 85. So our answer, we'll have to leave as the square root of 85. That is simplest radical form. Nothing we can do there. Let's take a look at question 16. Remember, midpoint. A lot of people get confused between distance, remember, distance and midpoint. So when you're doing questions 16, 17, 18, 19, remember, looking for a point here. A point, right? A coordinate, an x, comma, y in some sort of parentheses. Distance, we're looking for just one number, like 5 miles, 5 yards. But midpoint is a coordinate. So as you're doing 16, make sure you're writing down a point and not one number. 16 I'll do without any formula. Our midpoint is just halfway between these 2 points, so we can use half the rise and half the run to find that. So half the rise, half the change in y is 1, 2, 3, 4, 5. So half of 5 is 2.5. 1, 2.5. So it'll be right there. Half the run, let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so half of 7 is 3.5. 1, 2, 3.5. So right there. And so it looks like my midpoint is going to be right there. And so the coordinate of that point is negative 1.5, negative 1.5, comma, 1, 2.5, negative 2.5. That's without using the formula. If you'd like to use the formula, we'll use the formula on 17. So the formula, remember, is x2 or x1 plus x2 divided by 2, and y2 plus y1 divided by 2. We're just adding the x's together, divided by 2, and the y's together, divided by 2. Again, I don't like using the formula. I like doing it the way that we did in the first one, but if you like using the formula, here it is. The coordinate of this point is negative 2, comma 1. The coordinate of this point is 2, comma 2. So my x1 and my x2 are negative 2 and 2. So negative 2 plus 2 over 2. My y2 and y1 are 1 and 2. And of course, this could have been y1 and y2. It doesn't really matter. We're adding them. 1 and 2. That makes 3 over 2. Oops, sorry. 1 plus 2. I skipped a step. 1 plus 2 over 2. Negative 2 plus 2 is 0. 1 plus 2 is 3. 0 over 2 is just 0. And 3 over 2 is 1.5. So the midpoint here is 0, comma 1.5. And to double check that, 0, 1.5 right there. Yep, that is the midpoint. Remember, midpoint should be a point, not a number like distance. It should be a coordinate, 2 numbers, in parentheses, separated by a comma. 18, I will do without a formula. Let's see. I'm going to figure out, remember, when you're doing midpoint on a graph, you're kind of doing half the rise and half the run. Without a graph, you can kind of think of it as an average of 2 numbers. What number is right halfway in between? So between 0 and 7, what number is halfway in between 0 and 7? Halfway in between 0 and 7 is 3.5. So my x value is 3.5. What number is halfway between negative 2 and 4? If it's hard to visualize or think about in your head, you can kind of do this. All right, negative 2 and 4. So what's halfway between negative 2 and 4? It's positive 1. So the midpoint of this is 3.5, comma 1. Done without a formula. Number 19, I will do with a formula, although again, I prefer to do it this way. But if you like the formula, it's right up here. Add the x's together, divide by 2. Add the y's together, divide by 2. You've got your coordinate. So here we go. Add the x's. 4 plus 0, divide by 2. Add the y's. Negative 6 plus 2, divide by 2. 4 plus 0 is 4, divided by 2 is 2. Negative 6 plus 2 is negative 4, divided by 2 is negative 2. So 2, comma negative 2 is our final answer for 19. Remember, that's the midpoint, halfway between these 2 points. Whenever possible, I recommend using not the formula, because I think it's easier, it's less to remember, but the formula is there in case you'd like it. Question 20. Find the slope of each line. Then write the slope of a parallel line and a perpendicular line. So let's remember. Slope can be found many ways. Rise over run, change over x over change in y. There's also a formula. Parallel has the same slope. Two parallel lines have the same slope. Remember, they're looking like this. Same direction, same slope. Perpendicular line has opposite reciprocal slopes, also called keep, flip, change. Let's dive into 20. The slope of line 20, well, I'm going to use just basic rise over run. Going down 1, so that's rise of -1 over 1. So my slope, all right, m, is -1 over 1, or just -1. A slope that's parallel, so all right, parallel to m, is going to be the same as that slope, so also -1. Could look something like maybe like this right here. It's got a slope of 1. And a perpendicular slope to m would be keep, flip, change. So if I took this fraction, I flipped it over and changed the sign. So that'll be 1 over 1 and making it positive. So just a slope of 1, I guess. And a perpendicular slope might look like this, slope of 1. So up 1 over 1, up 1 over 1, just something like this. And you can see that it is in fact perpendicular. Right? For 21, let's take a look at this. The slope of this line is, let's see, over 2 up 1, over 2 up 1. Or I guess you could say over 4 up 2. So the slope could be maybe over 4 up 2, so rise over run. 2 over 4 simplifies to 1/2, positive 1/2. And that is a positive slope, so that makes sense. A slope parallel to that line would also have a slope of 1/2, or parallel has the same slope, so it could be something like this. Right, this is an example of a parallel line with the same slope, over 2 up 1, over 2 up 1. A perpendicular slope, remember, has that keep, flip, change. So I take my fraction, I flip it over to 2 over 1, and change the sign from positive to negative. So simplified, that's a slope of -2. So if I try and make that slope, that would be something like down 2 over 1, down 2 over 1, like this. And you can definitely see that it has that negative slope and that it is perpendicular. Makes a 90-degree angle to my original line. Question 22 and 23 are done basically the same way. Question 22 I will do without a formula, no slope formula. Question 23 I will do with a slope formula. So, first 22. Without a slope formula, all I've got to do is look at my change in y and change in x. My change in y. How far is it from 15 to 13? Decreasing by 2. Change in x. How far is it from 10 to -6? I'm decreasing by 16. So my change in y over my change in x, negative over negative makes a positive. 2 over 16, if you divide the numerator and denominator by 2, you will get 1/8. Okay, so this is a slope of 1/8. The slope of a parallel line, I'll do right here, so parallel slope, would also be 1/8. And a perpendicular slope to that line would be, remember, keep, flip, change, so I'd flip that fraction over, get over 1, I'd make it negative, and I guess I could write that as just the slope of -8. So there's my 3 slopes. Question 23, I will do with the slope formula. Remember, the slope formula is y2 minus y1 over x2 minus x1. So, let me label my points, x1, y1, x2, y2. So let's see, y2 is 3 minus y1, which is also 3. Okay. X2, which is -15, minus x1, which is -2. So minus -2, I guess I can write that as just plus 2. Minus negative is a positive. 3 minus 3 is 0. -15 plus 2 is -13. And 0 divided by 13, well, 0 divided by anything is just 0. So the slope of this line is 0. Remember, it's going to look like a flat line then. So what's the slope of a parallel line? Well, a parallel line would have the same slope, so it's also 0. Right? Something like that. This next part is tricky. A perpendicular slope, what Well, can I really do an opposite reciprocal of this? I guess I kind of could. I could take this and flip it over and change the sign, so positive instead of negative 13 over 0, something like that. But I can't divide by 0. What's going on? Well, if you think about a flat line with a slope of 0, the perpendicular line would be straight up and down, right? And remember, the straight up and down line has an undefined slope. We get undefined again when we divide by 0. So either way you look at it, the perpendicular slope will have to be an undefined slope. Undefined. That ends question 23 and this review packet. If you have any questions on anything in this review packet, please come see me after school, during class, or during advisory. Remember to study the words on the back for vocab. The following words you do not necessarily need to study, but if you know them, you'll get extra credit. You do not necessarily need to know the word similar, altitude, CPC/DC, which are 48, 49, 51, and 53 respectively. You will not need parallelogram, 59, all the way down through secant. You do not need to know any of those words. However, if you do, they could come for extra credit. You do not need to know cone, which is 89, all the way down through oblique, which is 99. You do not need surface area, and you do not need volume. So all those words you will not necessarily need to know on your midterm. However, if you know them, they may come up as extra credit questions. Good luck!